Hi everyone. Today I want to talk about Anova. Anova, isn't that fun to say? So my name is Josue Sanchez and we're going to be looking at what analysis of variance means and how do we use it. So let me back up a little bit. So this is a very familiar term in statistics. Anova is very much like a t-test, except we add a couple more elements to it. So let's go ahead and look at what Anova means by looking at the definition from our textbook. So defining Anova, it's an analysis of variance, a test for the difference between two or more means. A simple analysis of variance, or Anova, has only one independent variable, whereas a factorial analysis of variance test that means more than one independent variable. One way analysis of variance looks for difference between the means of more than two groups. So when to use Anova? There's 3 steps to determining whether Anova is the right type of test for you to judge variances. Let's look at it. So step 1, you have to ask yourself, are you looking for relationships between variables or examining the difference between one or more groups? That's really the key here. Now we can use t-tests to examine things within the same group, but Anova is great for looking at various different groups. Step 2, are the participants being tested more than once? If your answer is yes, then you'll probably use a t-test. If you answer no, then Anova is right for you. How many groups are you dealing with? If you're dealing with more than 2, then Anova is a great choice because it allows you to compare the different means of the different variances. Now let's look at one study that used Anova to find correlations between 2 different sets of tests. This study was entitled "The Correlations Between Modes of Student Cognitive Engagement and Instructional Practices in Undergraduate STEM Courses" by Allison Barlow and Shane Brown. Now what they were looking for was, how does instructional patterns affect the cognitive experience of the students? Now this type of question is one of the great questions that we can answer and address using Anova. Let's look at the study overview. Students from 19 STEM courses participated in a self-report and analyzing various factors in their classroom experiences. The students' report was compared with a more traditional post-secondary instructional practice survey, which teachers usually complete. This study examined if there was a correlation between the instruction and the student experience. More specifically, how did the physical setup of the room affect how the students learned? Now, the students were given a student course cognitive engagement instrument test, or SCCEI. This measured 5 different factors within the class. 1, the interactivity with peers. 2, constructive note-taking. 3, active note-taking. 4, active processing. And finally, passive processing. The researchers used a 2-way repeated measure Anova that allowed them to individually evaluate the effects of the physical classroom structure on the students' scores on all 5 factors of the SCCEI. The study results showed that peer interactivity was correlated with instructional practice in the study, suggesting that collaboration within the classroom should be a priority for instructors when designing classroom layouts and lessons. Now, if we look at the data from the research, we can find that there in fact was correlations that are highlighted here on table 8. Now, this is a partial correlation matrix of the SCCEI and PIPS. In table 6, we see the descriptive statistics of Anova datasets. Now here we can see the differentiator, the variable, the SCCEI factor, the mean, and then the standard error. I want to thank you for watching and have a great day.